So let's go ahead and erase these stray marks. And now that we have completed step one, we found the midline, the top and bottom line, let's talk about how to get those important t-coordinates. Those were these 5 coordinates here along the t-axis. Now, I do want to make an observation that I think will help about the parent function here and these important t-coordinates for the parent function itself. So for this parent function, there are 5 of these t-coordinates. 1, 2, 3, 4, 5, and they are all equally spaced. And what we'll do is we'll transform these 5 equally spaced t-coordinates to get 5 equally spaced t-coordinates for our transformed function. Now, what you could do is literally transform every single one of these points. So transform the x-coordinate x equals 0, x equals pi over 2, x equals pi, etc. And by transform here, I mean apply only the horizontal transformations. However, I think it's easier to first transform the first and the 5th point, and then find the other 3 points, the other 3 t-coordinates here, by using the fact that all of these t-coordinates have to be equally spaced. So let me show you how that might look if we didn't know these middle coordinates here. So let's suppose that we didn't know what these middle t-coordinates were, but we knew the first one, which was which is t equals 0, and the last one, which is t equals 2 pi. So if we knew that the first one was t equals 0 and the 5th one was t equals 2 pi, like we have in this drawing here, and we wanted to split up the interval between 0 and 2 pi and find these 3 other equally spaced points, then I think the easiest way to think about this is first find this 3rd point, which is halfway between the 1st and the 5th. So this 3rd t-coordinate would be halfway between t equals 0 and t equals 2 pi, and to find a number that's halfway between 2 other numbers, you do what's called the average. So you do 0 plus 2 pi and divide by 2. That's the average of 0 and 2 pi. And you would get, of course, 2 pi divided by 2, which in this case is pi. And so this 3rd point, this 3rd t-coordinate would be pi. Then you can find the 2nd t-coordinate because the 2nd is halfway between the 1st and the 3rd. So to get a number that's halfway between the 1st and the 3rd, you would do 0 because that's the 1st, plus the 3rd, pi, and divide by 2, and that would be pi over 2. And then finally you could get this 4th t-coordinate, which to get that one you would need the average, or the t-value that's halfway between the 3rd and the 5th. So that is pi plus 2 pi divided by 2, which is 3 pi over 2. So we can fill in our pi over 2 and our 3 pi over 2. And so what I'll do here in order to find our important t-coordinates is we'll start, of course, by listing the transformations. So listing specifically the horizontal transformations. And if we go back, we see here that this is a left shift by pi over 2. So we could go about finding the important t-coordinates for our transformation by taking each t-coordinate and subtracting pi over 2. So we started, the first important t-coordinate was 0. Can subtract pi over 2 and get minus pi over 2. And we could do this for each one, which actually looks to be a little bit easier than the method that I just discussed. But there are plenty of problems for which the method I discussed is easier. I think I'll do it both ways. So the second t-coordinate, you would take the second t-coordinate of the parent graph, which is pi over 2, and you would subtract pi over 2, and you get 0. And you would do this for the others as well. Pi minus pi over 2, that's pi over 2. Then the fourth t-coordinate would be 3 pi over 2 minus pi over 2, which is 2 pi over 2, which is pi. And then finally, you have 2 pi minus pi over 2, which is 3 pi over 2. And again, the other way to go about doing this is to transform the first and the fifth. So the first would be 0 minus pi over 2, which is negative pi over 2. And then the fifth is going to be 2 pi minus pi over 2, which is 3 pi over 2. The third, which is halfway between the first and the fifth, is going to be the average of these two, which is minus pi over 2 plus 3 pi over 2 divided by 2. Now 3 pi over 2 minus pi over 2, that's 2 pi over 2, which is simply pi. So this ends up being pi divided by 2. To get the second, you do the average of the first and the third. And this may seem a little strange when you're doing the computations, but remember, you have the first and the fifth, and the third happens halfway between the first and the fifth, and the second happens halfway between the first and the third. So this would be minus pi over 2 plus pi over 2 divided by 2, and that's just going to be 0. And then the fourth happens halfway between the third and the fifth. So that would be pi over 2 plus 3 pi over 2 divided by 2. And pi over 2 plus 3 pi over 2, that's going to be 4 pi over 2, which is 2 pi, divided by 2, which is simply pi. So you get the exact same thing. It's just whichever is your preference, you can choose what you'd like to do. I'll typically default by doing this sort of averaging technique where I find the first and the last, and then I average in order to obtain the third, then average to obtain the second and the fourth. But in any case, we have the 5 important t values here. So we can go ahead and put them in order 1 through 5 onto our coordinate plane. Now in order to do this, we'll need to create a scaling, and I think what I'll do is I'll make this to be pi over 2, then this would be minus pi over 2, then this would be pi, this would be 3 pi over 2, and that's all we need to sketch one period. So we have on our graph the information that's needed. We have our midline, we have our top and bottom lines, and we have, oh, I suppose I forgot to put my second important x-coordinate, which is 0. We have our 5 important t-coordinates. And sorry if I keep saying x-coordinates. A lot of times in homework problems these will be x-coordinates, but I've been using t. And let's go ahead and make it so these plus and minus 1s are not covered up by my top and midlines. And now we're ready to do part 3, where we sketch the graph.